50 degrees below zero outside, comfortably above freezing inside. Same structure, same walls, and those walls are built entirely out of the thing that's trying to kill you. That's the paradox of the igloo, and the answer isn't magic, it's physics. The Inuit worked out through thousands of years of survival, long before anyone had a word for thermodynamics. Start with the biggest misconception. An igloo is not an ice house. Solid ice is actually a poor insulator, because cold slides straight through a dense block of it with almost nothing to slow it down. The material that makes an igloo work is compacted snow, and compacted snow behaves nothing like ice. Fresh snow can be up to 95% trapped air, held in place by a loose lattice of ice crystals. That trapped air is the same principle behind a down jacket or a foam cup. It isn't the solid material that blocks the cold, it's the countless tiny pockets of still air sitting inside it because air conducts heat poorly and heat has nowhere fast to travel through it. Building an igloo isn't building a freezer. It's wrapping yourself in a thick white blanket that just happens to be load-bearing. Nature figured this out long before people did. Polar bears dig snow burrows to den through storms, and grouse bury themselves under fresh powder on brutal nights, using the exact same trick. Even plants rely on it, since a deep layer of snow over soil traps the heat that built up underground during warmer months, keeping roots and seeds from freezing solid. The Inuit essentially borrowed a survival strategy that had already been tested by an entire ecosystem. But insulation alone doesn't warm anything. An empty igloo left overnight sits at exactly the same temperature as the outside air. Because insulation only slows heat loss, it doesn't create heat. That heat has to come from somewhere, and that somewhere is you. The human body constantly radiates warmth, and once that heat is trapped by walls that barely let anything escape, it starts to accumulate. Add a small stone lamp burning seal oil or blubber, and that modest flame combined with a couple of bodies can push the internal temperature up to around 15 or 16 degrees Celsius, even while the world outside sits near 40 below zero. That's a swing of close to 100 degrees Fahrenheit, produced with nothing but trapped air and a bit of body warmth. The shape of the igloo does its own quiet work too. Warm air rises and cold air sinks. So traditional igloos are built with the entrance lower than the living space, often through a short tunnel dug beneath floor level. Cold air pours into that low tunnel and stays trapped there, while the warmest air collects up near the dome, right where people sleep, usually on a raised platform positioned specifically to catch it. There's also the dome itself. Cut a real igloo in half and you won't find a smooth half circle like the cartoon version. You'll find a shape called a catenary, the same curve that forms naturally when you let a chain hang loose between 2 points. That shape spreads weight evenly across the whole structure instead of concentrating it at any single spot, which is why an arch of stacked snow blocks can hold its own weight and a person's without buckling. It's one of the most stable shapes in architecture, and Inuit builders were using it for shelter centuries before it had a formal name. There's one more detail that seems like it should ruin everything. Body heat inside the igloo slightly melts the innermost layer of snow. That sounds like a structural failure in progress, but the cold seeping in from outside refreezes that thin melted layer almost as fast as it forms, turning it into a smooth shell of solid ice along the inner surface. That shell seals every gap and crack, cutting off drafts and making the whole structure stronger the longer people live inside it. The very process that should collapse the igloo ends up reinforcing it instead. Put those pieces together: insulation from trapped air, a steady source of heat from the people inside, an architecture that channels warm air upward and cold air downward, and a curved shape strong enough to hold itself up under its own weight. None of it requires a thermometer or an engineering degree. It requires paying close attention to how heat actually moves, something Inuit hunters mastered through necessity long before physics textbooks existed. The result is a shelter that turns one of the harshest environments on Earth into something not just survivable but livable, built from nothing more than snow, patience, and a working understanding of the cold itself.